Hi guys, welcome to the course on neat programming in Excel and its basic features that sometimes are hidden to the everyday user. I use Excel every day. I use Python and I use web programming interfaces to present data from various sources, including Excel. I also use MySQL and SQL Server, products by Oracle, and products by Microsoft. I hope you enjoyed today's lecture. I'm really going to cover the basics of all those topics as a test for Udemy as I produce my first learning modules. Without further ado, this is an Excel spreadsheet. What I've done is I've created a couple of functions and I'm going to walk you through what we are accomplishing step by step. For the first part, Excel offers several tools that incorporate programming and visualizations. It is a unique product worth millions, if not billions, of dollars. You'll notice on the screen that we have borders. I've created some borders so that you get a feel for what types of things that you can do in Excel that mimic an integrated data environment. We'll go into what an integrated data environment is at the end of the next lecture. And our goal in this lecture will be to understand the features and advanced capabilities that Excel offers programmers. On this slide, you'll see several features that are available to programming interfaces, whether you're on a home computer, on a network, on a portal at work, or on a website. On the left, top, and bottom are margins that are written, I would say, in a light gray and fairly offset, not too much, not too little, to capture the essence of what amounts to an interface. So Excel is often used as a table or a database, but it can also be used to summarize data, much like a website would. For this programming lesson, we're going to incorporate some functional statistics that most programming languages use. If you're new to statistics, we can discover basics here, which include taking the lowest, highest, and average values of a data set. As an example, we often think about populations. Populations are a large number of individuals with features. You might consider the population of high school students in your hometown as an example. Beyond the statistics of minimum, maximum, and average value, a statistician often will talk about a standard deviation. If you look at the cell D3, we have a standard deviation button. When I hover over the button, like so, I see that I'm prompted to get the interval. Select standard deviation. Let's not deal too much with what standard deviation are, but you'll notice that I have three options. 1 for standard deviation range 1, 2 for standard deviation range 2, and 3 for standard deviation range 3. Let's select the middle value. The standard deviation attempts to capture where a majority of the population stands as far as a characteristic. In the case of high school students, we could look at the height and weight of high school students who range in age from about 14 to 17. You and I could analyze the statistics on the fly or in real time and assume that most students have a range in height from 5 feet, which is maybe a shorter woman, to 6.5 feet, which is maybe what a basketball player or tall man would rise to. That's quite a deviation. Some children are 5 feet tall by the time they're in 4th or 5th grade, and many people won't reach the height of 6 feet. Imagine you are a high school tennis coach or drama teacher, and you're instructed to provide some form of costume or athletic gear for those students. In general, you want to have an idea of what size and cost is involved. A good way to start is to consider who might win the part of the leading man or who might win the part of the quarterback. How many jerseys do I need for a particular size? And standard deviation offers us an alternative to doing everything manually or based on a guess. A standard deviation would say, I know within reason that a majority of the students will fall within this particular range. Standard deviation range 1 talks about where 66% of the population will stand. It's strongly correlated with the average. So if the average height of students in high school is 5'9", you would be hard-pressed to not find a great majority, if not 66% of your student athletes or actors to have that build, about 5'9", what you might call a large size. Perhaps the populations deviate from gender. Perhaps we need to consider the gender and limit the scope. These are questions that we ask in daily life, whether we are coaches, teachers, or professors. You'll notice when we select the standard deviation number 3 that cell K6 changes to 95. Again, standard deviation can range from 66 to 85 to 95. And what we did is we looked at the deviation correlation table for 1 standard deviation, 2 standard deviations, and 3 standard deviations. We've selected number 3, and if we select number 1, you'll notice that cell K5 became 66, 1 standard deviation. What's important to note here is not the mathematics or the statistics, but the goal or the objective was to capture the range in height of students from age 15 to 18. Where will a majority of the students be in terms of height? Again, when you look at step 2, we are hovering over this cell here, and it's in cell P4, and it's talking about confidence intervals. I have an 85% confidence when I use 2 standard deviations that I will capture 85% of the population. So there will be an age, so there'll be a range in values for height and weight that may range from 125 pounds to 175 pounds that captures 85% of my statistics. So this simple formula can be applied in Excel as a user interface. You'll notice that the letter changes from A to B to C when we change the confidence interval. Let's select a different standard deviation. When I select the second standard deviation, it correlates to 85% confidence. And when I go down to my lookup table, it changed from A to B, and my unit mean is now, in this case, the number 6. What I did was provide some random variables, but if we insert, let's guess 180 pounds as an outlier. Actually, we have a preset value here, range 1, range 2, range 3. That's the sort of value that I can choose from, and eventually we'll populate this with actual weights. But all I'm doing is showing you that we can create a spreadsheet that acts like a program to tell us what is the average height and weight of students. So this concludes the introductory session on using Excel as a graphical programming or integrated data environment. Stay tuned for part 2. Heartedly about watching the video on introductory applications, features, and concepts to make you a better programmer. We've used Excel. We've talked about the correlation of using Excel functions and programming at the command line interface. We learned that a block of code is similar to a cell and formula that are found in Excel. Excel is a very rich environment through which to take numbers and present them. We learned that cells can take more than one value, much like a variable can take many variables, many other variables, or perform a calculation. Excel calls the calculation a function, and when it's saved, it can be called by that name. There's a lot going on in Excel that correlates to programming languages, and it integrates a fairly straightforward user interface to do nice visualization. What we learned today is that we can customize some of the use of library functions to provide a combination of activities, taking data in one cell and outputting it in another, and then using it over and over again in a sequence. That sequence relates to programming and what amounts to system design or software engineering. We have 2 or 3 functions that we were trying to do. Excel has a library of functions and it saves it as a particular name, but we can go into the back end and create more functions in Excel. In fact, we wouldn't do that because we have enough to work with. However, in other programming languages, we will use a similar feature, a library name, or create what amounts to a user-defined function, which we will discover is beyond the scope of this. But in the next video or the next presentation, that's what we shall discuss. I hope you've enjoyed today's video. Thanks for watching. I'm Ed, and I work at Exeter Analytics.